Welcome, fellow lovers of mathematics. Today we're going to go over inverse functions. And an inverse function is just a function that undoes the action of the original function. And before we get into what an inverse function is, let's talk about what a function actually does. A function maps an element from a domain to an element in the range. And so one way to think of this is map directions. So for instance, let's say you're in a class and there's the door, and we'll say there's a little hallway here, and then over here we'll do another little hallway, kind of a small hallway, but that's okay. And then we'll just say there's the door to get outside right there. All right, so basically to get out, first you got to exit the door, you turn right, and then you turn left, and then you exit the door. So let's go ahead and write these down. The function that takes you from the class to the office. Oh, office. All right, so we'll say that's the office there. There we go. So first thing you do is you exit. Right? Exit the class. Second, you turn right. And then you turn left. And then you enter the office. And that's it. You're in my office from this pretend classroom right here. And this is the function that takes you from the classroom to the office. Now, what is the inverse? Well, the inverse takes you from the office and brings you right back to the class. So let's go through the steps here. First thing you do is you exit the office. And then you get to here and you turn right. Now you turn right. The class is right there on the left, so you got to turn left. And after you turn left, then you enter the classroom. And there it is. So let's note a few things. Same number of steps in either way. Note that the inverse function does a couple of things. One, it does all of these steps but in reverse order, and it does the opposite of what they did. So for instance, here, the first step was exit the class. Here, the last step was enter class. Over here, turn right. Go down to step 3, turn left. Here, step 3 was turn left. Over here, turn right. And then the fourth step, enter office. And here, the first step is you exit the office. And so that's something that whenever we get to finding the algebraic inverse functions, you will also notice the same pattern. Basically, the order of operations will be reversed, and they will do the opposite of what the original operation did. And let's look at this in a little bit more detail. What is the domain of the original function? Well, the domain of the original function is just one item, the class. And the range of the original function is the office, right? Because that is the only output for this function. Now let's look at the domain of the inverse. The domain of the inverse is the office. And the range of the inverse is the classroom. And so note that the domain of the function is the range of the inverse. The range of the original function is the domain of the inverse. So they switch places, the domain and range do, when going from the original function to the inverse function. So let's revisit composite functions, right? F inverse composite F of class. We'll note that this is simply the same thing as the inverse function acting on the original function of the at the class, right? The only element in the domain. And what is f of class? Well, f of class is the office. And the inverse acting on the office, you look up here, it's just the class. And so note that the input here, class, is the output. The inverse function undid the action of the function, right? Because essentially what happens is the function takes you from the classroom to the office, and then the inverse function takes you from the office and brings you right back to the class. Now let's look at this in the reverse order, where the function acts on the inverse, and we're picking office because that is the domain of the inverse function. And what is the F inverse acting on the office? Well, that's class. And what is F of class? Well, that is back to the office. And again, the input is the same as the output. What happened here is that the inverse function, you're starting off in the office, and the inverse function took you from the office to the class, and then the function brought you from the class right back to the office. So again, note that the input is the same as the output. And so, more technically, note that the domain and range swap places with each other. And so our definition for an inverse function is that an inverse function is that the inverse function undoes the action of the original function. And if it does not undo the action of that original function, then it is not an inverse. So this leads us to our following test to verify that a function is an inverse. If I take f of g of x and the output is simply x, and then also if I do g of f of x and the output is x, then they are inverse functions. Now, you are not setting these equal to x. I see all sorts of silly chicanery on exams where people try and set them equal to x and then solve for x and then come up with answers that are completely wrong. Don't do that. Remember, all you're doing is running this to see if it equals x or if it doesn't. So I want us all to write a question mark above the equal sign to remind ourselves that we are just verifying that it equals x. This is like a litmus test, right? If it equals x, it's an inverse. If it doesn't equal x, it's not an inverse. It's just as simple as that. Do not overthink it. So let's look at this first one here. We've got the cubic root of x, and we've got for g the cubic of x. So first we do f of g of x. Right, because g of x is really x cubed. Right, plugging that into here. Right, and this works like this. 3 over 3 is 1, and that equals x. So far, so good. Note that I just put a check mark there, right? I did not set it equal. I did not try and solve for x or anything silly like that. That's all I did. Now we test it the other direction. So I've got g of f of x. And so now this is g of x to the 1/3 exponent. So we've got this right here. And so again, we've got x to the 3rd over 3 like this, which is just x. Input is output, input is output. So they are inverse functions. So we state our conclusion, just like so. That's it. Next, we're going to look at f is the inverse function and g is the inverse function. And we're going to see if the inverse function is its own inverse. This one, note that f of g of x is the same as g of f of x. So we're only going to do this one direction since it's the same regardless if I have f of g or g of f. Right, so this is f of 1 over x, which is 1 over x, which is the same as 1 divided by 1 over x, which is 1 times x over 1, and that's just x. So it works out f and g are inverse functions. And the only reason I only had to do this one direction is because f and g are the same function. If they were different functions, I would have to test it both ways. All right, so next one. F of g of x again, which is f of x plus 2. And so we plug that into f. Which gets us 1 over x. And note that does not equal x. So we say our conclusion is that they are not inverses. Because once I've shown that one of them doesn't work, then neither of them work, right? They're just not inverse functions of each other.